Okay, guys, let's go ahead. So this is just getting the software. Okay, so let's look at that real quick. So if you type in students.autocad.com, students with an s.autocad.com, it'll take you to this website. And we looked at this briefly last time. If you go under college and university, this will take you to another website. And what you can do is create an account. Let's sign on. It used to always be right here on the right. What did they do with it? This way. Okay, so they've changed the site a little bit. So if you go to sign in, need an education account, you click here, you give some personal information. Make sure you use your .edu. Okay, that's how they confirm you're a student. Okay, otherwise everybody will be downloading this stuff. It's going to be important to make an account because ultimately when we start doing the analysis, we're using their cloud. So we're uploading the file, okay, and then downloading the file.
You do this before or after?
This is the first thing you do.
Oh, before you can download Revit.
Yeah, you have to make an account to even get access to download. Okay? So you come here, you make an account, put your country, date of birth. Again, you can lie on everything except your email because you'll have to confirm that. So, you can make everything else up, but use the correct email. Okay? Then you go next. You'll get an email confirmation, and then you'll be able to sign in. So then you can sign in. Don't use my sign in because we'll see what my login is anyways. But so to confirm everything was well, you should sign in because this is where after you sign in, I'm signed in now, I can find the software. So what we want to do is go to free software. Check your email and confirm. They want you to confirm the registration. And then you have to look for Revit. So you see how many pieces of software they own. It's quite scary. It's in alphabetical order. Revit. So you just want Revit. Do not grab Revit Architecture, Revit MEP. These are older versions. This is the newer version. Okay, so you're going to grab Revit. Click on Revit. You choose your version. 2014 is the newest. That's what we have in the lab. You cannot save down in Revit. So pick your language. And then Windows. So it never said that. Because it's 32-bit, 24-bit. It should work on any operating system. You saw a note somewhere that it said it's not compatible. Let's see. So after you're here, this is going to be, don't use my serial number. You'll have your own. So you'll get this also in an email. And then you install now. And this will take a while. It's a pretty heavy program. So depending on where you're at doing this, it might take 5 hours. It could take 2 hours. It could take a half hour. Again, depending on what type of internet you have access to. So assume that's going to take a little bit of time. So after you do that, you should be able to run the software. So I loaded this last week, and this computer is pretty old. It does have Windows 8.1. But it was able to open quite efficiently. So this is what the software looks like after you open it. Okay. So what are we going to be doing in here for this sort of go around? Is one, just to get a little bit familiar with the interface. And number two is to sort of replicate what we did in eQuest. Okay, so we have a building envelope that we're working on, and then we have a certain amount of glass that we want to test. You'll see at the level we're going to be working at, we're going to use ultimately a different analysis engine, but for now we're going to work what's called in conceptual mass. So we're doing a real simple mass. The massing model is actually going to look identical to what eQuest shows you. Like, oh, here's what your building looks like. So it's really early preliminary analysis. Okay. So I have some notes that's on, like how to find this stuff, but the in-between steps is where it's you need this video. So I'm recording. So you're going to start with architectural template. Why architectural? At any point we can switch our template. We can load in a template. Later on when we start our actual case study after the break, I will show you how to transfer families and talk a little bit more about families then as well. But just so you guys get a feeling for the interface, Revit is a 3D modeling software per se, right? And it's considered a BIM, building information model. So typically, if we worked in AutoCAD or if we worked in another sort of 2D software, we're always drawing 2D information, right? So majority of us have probably done that at some point, or if not currently doing it. You're modeling everything representing sort of a plan or a section as line geometry, right? So there's no dimension to it. It's just flat, as if you were on a drafting table drawing with a pencil. The big difference here is we model everything in 3 dimensions and then use the 3D model to produce 2D drawings. So the advantage of this is, A, we have something that's representing our building in 3D in the sense of walls, roof surfaces, interior surfaces, what's glass, what's not. That's real, sort of, not real objects, but objects that are really true to size, scale in the computer at 1:1. So we're working obviously at 1:1, which means 1 foot equals 1 foot. And then that piece of wall is representing a certain material that we can assign to it. We can assign quantities, performance, and then run an analysis or run a schedule of quantities. So it's a whole different way of sort of working or interfacing with a software because we're building something 3-dimensionally. So it does take some understanding of how do I navigate in the 3D world. Although I always joke with people like we're in a 3D world. So somehow people have a better time with 2D, but we've been in 3D since we were born. So I think you just got to wrap your head around that and say, okay, it's 3D. It's actually easier, right? So the idea is potentially it's easier. The hard part is we need to spend the time to build the 3D, right? So when we do 2D drawings, we're omitting tons of information, right? We're not cutting sections every, inch through a wall. We do some key sections, we do some key plans, and then we keep our fingers crossed that everything else is going to fit, right? So in this case, it's the other way around. We build sort of the envelope, we build a lot of the components. Do we draw every screw? No. Do we draw like every fitting to have every piece of detail? No. They're still abstracted pieces of geometry. And then rather than maybe adding physical model detail, we add data to it. So we add, data in the sense of if we know there's a certain amount of CFM moving through something, we can say there's a certain amount of CFM. Rather than maybe trying to model a specific, pipe size. Although we will do that in this class, sometimes it is just basic line geometry that has more information to it. So it ranges. One thing is maybe not a bad idea is like open a project, and you can see because now Revit has changed its sort of interface to sort of encompassing both architecture, structure, and mechanical, systems within one project. It gives us three options to look at, three different things. So we can ultimately, I'm not going to do this because we don't have time, but it's not a bad idea to open one of these and sort of navigate your way through it, in the sense of how you would test drive a car, right? Get in and start pushing the buttons. And this is something you can't break, right? Because it's not yours. So definitely push the buttons. Okay, that's the best way to learn the software, is sort of tool around. We're going to start by making a real basic envelope, which is based off of the earlier, the last assignment you did. So the first thing is to get into a template. So we're going to use architectural template. Before I click on this, let's just look at two categories here, which are project and families. As you can see down here, they have a table, some type of truss system, and some type of diffuser, it looks like. Families are basically all the pieces that make up the project. So project is where we assemble everything. Families are all the parts that get assembled ultimately in the project. Now, that being said, we can make families in the project. We can make families that embed within families, so it's not as cut and dry. You go from here to there. Sometimes you go from here to there, and then to there, or sometimes you work straight in the project. So, but I think it's important to understand the difference between a project is where we sort of compile all the information, and families is where we make the components. Okay? So this is a big drawback, especially if you're a new firm, just bought Revit, and it's like buying a new musical instrument. It doesn't play itself, right? So you have to learn how to play it. But not only that, you have to make families. More and more now, more and more manufacturers are developing the families for you. You'd be surprised, we can go on a website like a diffuser manufacturer, and they'll have Revit files for you. Every major window manufacturer has all the windows. Why do they do this? They do this because if they give it to you free, they assume you're going to take their family, use it in the project, and then eventually that family, they embed a ton of information on it, so it makes it to some type of specification that says you must, buy this window, right? And no one takes it off, and then there goes out the bid, and everybody's like, oh my God, we need to buy this. So they're smart, right? So they give this free stuff out there. So you just have to be aware of this. Sometimes, if you go to the bid process, I forgot what that's called. What's that? Yeah. So you have to take care of that. You know what's happening and why it's happening. But it's important to exploit and not sit there and build stuff. So we're going to use some basic components. We're not going to be building families. Okay. So let's go to architectural template. This will open up the main sort of working environment. So this will bring up the interface. It's going to look a lot different than AutoCAD for sure. Again, Revit was a software that was not developed by Autodesk. It was acquired. So it has a different sort of look off the get-go, although now everything's starting to look the same in Autodesk. So what do we see here? We see a top view. So it's set up by default, sort of us looking down in a empty sort of drawing that's not a black background but a white background. So this is our viewport. Similar to AutoCAD, typically we work in one viewport at a time, and that's controlled by what's called the project browser. The project browser is where we actually see a lot of information. Very important is we see our views. I guess I can't make that any bigger. So we see all our views, and all our views relate to specific architectural types of representational drawings, right? Plans, elevations, sections. And then we have other things like legends, schedules, sheets. So these are all relating to making, drawings. And then we get into families. So these are all preloaded families. So these are all components that are preloaded. We opened up an architectural template, so a lot of the preloaded families are architectural. So we're dealing maybe with doors and walls, but you see some piping systems, things that duct systems that also are part of architecture, but maybe not part of specifically what an architect might be working with. At any point, we can load additional families into a file, and a lot of times we'll do this just by bringing it in as a template. So we'll do this next week. For now, we're just doing really basic sort of modeling. What we have here is properties. Properties will allow us to change properties, so it's like our property editor. So if we want to change the property of a view, so whatever we sort of have active at that time, we'll sort of highlight. Okay. So browser, this is how we get to our different views. We'll look at levels and what those mean in a little bit. Properties is how we sort of change parameters. And then our ribbon here is where we start to generate different things. Architecture, we're going to make walls, doors, windows, different annotations. Structure, we're going to make structure, maybe foundation walls, beams. Systems is where we get into piping, any type of mechanical equipment, duct equipment, fixtures. So again, this is all in one thing now. Insert is where we can bring stuff from outside in. Annotations if we want to add notes. Analysis if we want to analyze, which we're going to be doing. And you can see now we have loadout, like if we're going to do structural analysis. We're eventually going to be doing, we're actually going to be doing heating and cooling loads, not for this exercise, but ultimately for our case study. But we do have this other energy analysis software that we're going to use here today. Okay, so they just like, this software is like, you know, how much stuff can you shove in the box? Everything that sort of that they're using, they sort of shove into Revit. Massing and site we're going to use shortly, but this is how we start to make an initial mass that we use for really early preliminary analysis. Collaborate is how we create a file that we can share in the sense of creating work sets. There are no layers per se in Revit. We use work sets to define our model. And then we might make specific work sets that define certain parts of the building. So say Jim wants to work on, you know, a certain part of a wing, and I want to work on a certain part. We're working from one file, but people sort of check out components or parts of the project. And you can see who has what. So we're not going to be doing any of this, but this is what you would be doing definitely in a collaborative environment like a firm. Synchronizing, then, that allows us to work off of a central file and sort of working with that. So we're not going to use any of Collaborate, but so you guys know what it is. View is how we adjust our sort of visibility of the project. Also how we might work with the windows, so we'll be using this on and off. Manage is how do we manage the file, so location might be one thing we're going to look at. So where are we located? Is going to be critical. And then modify is like when we select something, how do we modify it? Maybe beyond properties. Maybe we want to measure something. So we get sort of all our sort of tools, especially if we're working in 2D geometry. We might want to copy, rotate, erase, move, so forth. Okay? So this is the ribbon. We find these things along the ribbon. Again, this should be look similar to some like Autodesk product, like AutoCAD. But again, I think the interface is really different when it comes to how do we interact with the model. So the first thing I'm going to do is start to develop a real quick massing. So if we look here, let me get this to fit, sorry. So it's partially in the handout too, but obviously you're going to have a video, so you won't need this as much. But we are going to create a mass that's 250 feet wide by 150 feet deep by 22 feet tall, right? Because we're floor to floor at 11 feet. Okay? So we have to create a mass first. So that sort of is the envelope of the entire project. So to do this, we want to do is go to massing and site, and we're going to develop an in-place mass. So that means we're going to place a mass in the project. A lot of times we can make a mass as a family. There are mass families. So we can do a mass family and then reference that family into the project. Here we're going right into it. So I click on in-place mass. This is telling me like, hey, I'm going to enable mass. That's great. Let's call it something. So this is going to be, let's call it test build 01. You can call it whatever you want. This is just giving the mass a name. It's not that critical. And then we need to do a couple things. We need to draw the sort of the plan profile, 250 by 150. 250 by 150, and then we're going to extrude it. So we're going to do initially some quick 3D modeling. So unlike eQuest, where you just type in the numbers and it does it for you, here you have to actually physically do it. Okay? Which is the, how the software works. So I come here, I click on rectangle, so I'll draw a rectangle first. And then you can get lost in this. So this is you're in the Boeing 777, don't touch the buttons, you don't know what they do. So focus on what I'm telling you. Just touch the buttons I'm showing you, so because you can break something. So here's the rectangle. Click on draw on work plane. There's not a surface we can accidentally draw on, but get used to doing this. This draws it on a work plane. Now I know by default there's two levels in this file. Level 1, which is at 0, and level 2, which is at 10 feet. We're eventually going to change those. But level 1 is at 0. That's not going to change. That's our ground plane. So placement plane is happening at 0. That's our ground. So I feel that's correct. I'm just going to draw out a rectangle. So this is one easy way to get started in the software. You draw a rectangle out. Well, I know I didn't draw that 250 by 150, but I can change the rectangle. So if I hover over the rectangle and I pick an end condition like this line here, and I tab, I will be able to change my selection. So it's going from everything to just that one line. And I select that line. As soon as I do that, I get a dimension string that I can then modify. So I sort of throw down the rectangle, and then I hover over the line, and then I tab to pick just the individual. Now it's not hold down the tab. If you hold down the tab, you'll just go through the selections. You click until you get what you want. So I'm clicking the key. Once I get what I want, I click the left button on your mouse, normal button. Okay? So then I come here, I go to the text, I click on 128, and I type in 250 feet, so it lengthens it. I do the same here for the top, tab, click on the text, change that to 150, enter. My building now is 250 by 150. I'm then going to move into a 3D view. So I'm going to go then to view. Now I'm still in the command of massing. You can see that it says finish mass. We're not done. We need to extrude this. So I'm going to go into a 3D view, select that geometry. As soon as I do that, you see all these other things appear. And what I'm going to do is click on create form. Again, there's a lot of things going on here. Don't worry about it. Just click on create form. That's going to make the extrusion. It just knows that, oh, you want a rectangle? The only thing I can probably do with it is extrude it. So extrudes it straight up. By default, it extruded mine 90 feet. I go to that text and click on it, and I make it 22 feet. So now it's 22 feet. If I click off, there's my mass. I click on finish mass. Okay? Sounds good? Alright, now I got to define where my floors are. Okay? So I have just this big chunk of foam. Now I got to tell where the foam. you know, where the floors are, right? So to do that, I'm going to go to an elevation. So we're going to go to a north elevation, and we're going to look at our levels. Our levels are going to be defining top of finished floor. Okay, so we know we're going floor to floor 11 feet. I need to change my level 2 to 11 feet. So if I come here and click on the dimension, I'll get this dimension that allows me to change that to 11 feet. So that moves up to 11 feet. So I now have floor at 0, floor at 11 feet, roof. Okay? Don't need anything for the roof. I'm going to go back to the 3D view. So
20 feet tall?
22.
Oh, no,
I made it.
oh,
Yeah, I made it 22. So when I extruded it, I changed extrusion height to 22. It's all right. No. It's like a new world. All right, so now I have this. The next thing I need to do now is I select the mass. I need to mask the floors. So this is simulating where floors are. Okay? So I click on mask floors. I select level 1 and level 2. I know there are floors there, and I hit OK. This will put in floors. You need floors for the energy model. Otherwise, it doesn't realize there's floors, and it doesn't know what to do with it. So it thinks it's just a blob of nothing. Okay? So select it, mask the floors. Now we can start going to analysis. So we're going to run to analyze, energy. I want to click on this button here, which is use conceptual mass model. This is new. This is using we couldn't do this before so successfully. This actually, if we have like an architectural model, this is like the architect throws a model at you. You can use the actual building elements. I don't know, I think 2013 maybe they added this. I don't know. But I know it wasn't there in 2010. So now we're using the conceptual mass. I'm going to enable the energy model. As soon as I do that, you'll see something that looks similar to what we had in Equest. Okay? These are the 4 zones. You see how it's splitting it up? It does it at a weird angle. I don't know why. Like it doesn't take it at the corners like it should. But. So I'm always trying to remember. Each software has its own 3D orbit. It's shift right click. Shift right click does 3D orbit. So this just created something by default. We need to sort of modify this now. Okay? So the first thing I'm going to do, I like to do this under manage. I go to manage. We have project location. Let's find the location. I assume we did Chicago? Mm-hmm. Okay. So we come here. We can get really specific and like pinpoint something. It always chooses Boston. Autodesk is based in Boston. So we can go Chicago, Illinois. And it finds it. And then we hit OK. We can do this later in the energy model, but I like to do it there. Analyze. We go back here. We now go to energy settings. This is where we change the values. So we could have changed location here, but that's fine. So what type of building is it? Office, ground location, level 1. What do we have options here? Export category, rooms or spaces. It's not even, we don't need to worry about this right now. Don't have to worry about this. What we're going to be interested the most is don't worry about this. Core offset. So this is where we had what? 5 feet. Divide perimeter zones. We can uncheck that. Were they dividing perimeters? Were they had you had 5 zones you said per floor, right?
Floor and there were the corners. Yeah.
Okay.
It's okay, it's an automatic.
This is where it gets not as advanced. Under conceptual construction, you basically get conceptual construction. What is your exterior wall made out of? Lightweight construction, typical mild climate insulation. So you don't have the sort of refinement that you ultimately will have with the building. Once we start getting into building and like build components, we'll be able to give it U values, and those will translate into a different model. Okay, so we'll look into that, but this is what we have now. So it's dumbed down. So how do you translate this? This will be, come up with a scenario that is your base building. Okay, that fits. So this is sort of your homework, yeah? To do your first test run. So come up with,
So we're just supposed to put stuff
yes, based on what you think the base building might be. And I know you don't have the stringent requirement of a U value, but I can give you it, but I'd rather you guys maybe sort of pick something.
in it? Play with it.
Yeah. Just one. Pick one sort of base building scenario. And then when we come back, we'll look at a specific one. But I think for now, we're not really doing a comparison of what we need to have versus what the architect wants. This is more to get into the software. Okay?
Can you pick one of those? Will it tell you what the R factor is?
No.
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 Okay.
Yeah.
So like where it says mass skylight, can we opt to not have any skylight?
Well, we'll tell it no skylights. Yes, we'll tell we can control the amount of skylights we have. So it doesn't matter what you put here if you have 0 skylights. So, you know, like where the roof is, typical insulation. What is that? So maybe you start with a dark roof, you know, like worst case, and then look at, you know, high, cool roof, right? Maybe pick 2 extremes that you can just run a quick test on. You guys will have a challenge enough to get into the software. So I don't want to overtool you with, we're going to get into this more, but with the building. So we'll actually be using U values then. So this is sort of the first test. Okay? So after you do that, we can say percentage of glazing. Okay? And here you can see skylights. So if we have 0. This is sill height, how high it's off the ground. We also have default operating schedules. Is that something that's defaulted in eQuest as well?
Well, it's their default. I don't know if
Yeah.
it's the same default, but
Yeah.
acceptable.
And then you have some type of HVAC system, which by default in this case it's a central VAV. Maybe we can
Probably rooftop version.
looking for one. I know we used I think we just left it where it was there last time.
Yeah.
That'll work. Okay, so let's look at this 'cause I know we're running out of time. So not much changed here. After we do that, we run the system analysis. So run energy simulation. This is going to upload it to the cloud. So you got to be logged. You'll be automatically logged in. People pay for this service. Because you have an account, you get it for free. You accept. You give it a name. And you wait. So after that, this thing, we sent the results and compare. We can see our project test 1 is processing. It's not processing on my computer. It sent it to the Autodesk cloud. So it's at 41%.
It's basically simulating on the cloud.
Yeah. Because you wouldn't be able to run it on my computer. So they have whatever X amount of servers, warehouse full. And I forgot how much you pay for a subscription for this, but I'm sure it's not cheap. So we'll pause. So once it's done, results and compare. Let's pulling it from the web. You'll have all the runs you did in this project. So if I click on it, it'll take me to it. And then what do we get out of here? I mean, you get some things that are maybe, you want to know how many square feet you have. This is interesting. How many people might be in it. That's what they're assuming by usage. And that's all these can be changed. But it's defaulting because it's an office based on square footage. And then you get some, you know, but maybe the more important thing is what you're getting is the energy use. So this is giving me kilowatt hours in electricity. And this is breaking down energy use in fuel and electricity. So maybe this is something that has to be looked at, and you know, what useful information can we decipher out of this? Because there's, you know, it's a little gimmicky in how they sort of try to.
Is this project written down to me, like this homework or something?
It's in the I haven't spelled it out, but yes, there will be. It'll be posted. I'll post it in an announcement.
Okay, so just go to Blackboard.
Yes. But the idea is basically what I'm doing here, just run it twice. Okay? So I ran it once, so now if I go back, I'm going to close this. All I need to do is go back into my energy settings, make a change, 100% glazing, 95% is the hack, sorry. Hit OK. There's all my glass now. Run it again. Give it a new name. You'll upload it. Let's see if we get the summary page. So if we go to results and compare, we can go to compare. Oh, it's still I can't compare anything yet, sorry. It's at 33%, 50%.
Is it an email or something?
No, this file you can save. You save this. So when you save the Revit file, it saves the it saves this, it embeds it.
But it's been saved on the hard drive or something, right?
Yeah, so you need if you do it at the lab, you need to bring a jump drive with, or you need to email you the file. Email yourself the file. Okay? So what I do now, if I pick two of these,
So we're not gonna use this one going forward anyway, so we
No.
can but.
but if you want to keep it,
On the
yeah,
project, we're gonna need to stick.
yeah.
How big is this file? Okay.
You don't need a stick. You do get space on the Google Drive. So we can look at that in the lab tomorrow. I mean, sorry, I always say that, but next week, in 2 weeks. You get, I forget how much space you get in Google Drive, but it's quite a bit. So you don't need anything other than the internet and a computer. So if you have an internet connection, you can get your files anywhere. So we'll look at Google Drive. That's the best thing to use. So if I hit compare, it'll pull them both up. Okay. So what I'll ask you guys to do then, we can print this as a PDF on my computer. If you guys don't have PDF, just print the first sheet. It's only 6 pages. That is true. All right, print it. Print it. And then staple it, write your name on it, and turn it in. Okay? Yeah, and I think it'll be interesting to see if you guys can do this, but it should be. With the video, it's good.